All right, so today we're finally going to finish up the gas law stuff. We'll cover the ideal gas law today, and then I'll give you a quiz over all the gas law stuff. And if you could get that done for me by next week, I appreciate it. I'll give you a practice problem or two to go with this before we actually take the quiz. So, ideal gases, we're going to get the number of moles involved with this. So, the volume of a gas at a specific temperature and pressure, that volume is going to be dependent on the number of particles that are within that container. So, and we know that the number of moles is directly proportional to the number of particles. If we have 1 mole of any gas, we have Avogadro's number of particles. So, first thing I'm going to start off, I'm going to show you how we get our gas constant, which we use in this ideal gas law. So, the ideal gas constant we label as R, and we get R by taking our pressure times our volume divided by our temperature times the number of moles. And R is going to be equal to 8.31. That's our constant. That never changes. So for all these problems you're going to see, we're going to use 8.31 as our gas constant, which we represent with R. How we get 8.31? At STP, our pressure is 101.3 kPa. Our volume is 22.4 liters in 1 mole. Our temperature is 273 Kelvin. And we have number of moles is 1. So again, P stands for pressure, V stands for volume, T is temperature, and then N stands for number of moles. Okay? When you take 101.3 times 22.4 divided by 273, it gives you this gas constant of 8.31. So, we'll take this. The ideal gas law states PV equals nRT. Pressure times volume equals the number of moles times our gas constant times our temperature in Kelvin. Okay? So we can solve for the number of moles of a contained gas when PV and T are known. So, and we just rearrange that equation for R. So we can solve for any of these variables if we're given that. Again, pressure, volume, number of moles. R is our gas constant, which is 8.31, and then our temperature. Okay? All right, so let's go ahead and look at sample problem 12.5. And the reading does a nice job of kind of explaining the ideal gas law. So sample problem 12.5, and this is on page 342. So just follow along with me. You have a steel rigid container that has a volume of 20 liters with nitrogen gas to a final pressure of 2.00 times 10 to the 4th kPa. So our pressure is 2.00 times 10 to the 4th kilopascals at a temperature of 28 degrees Celsius. So our temperature is 28 degrees Celsius, just the 2 sig figs. And it's asking how many moles of nitrogen gas does this container, or does the cylinder contain? So, let's jump back up here. We're going to start with PV equals nRT. And in this case, it's asking what's the number of moles of nitrogen of N2 gas. So this is our unknown. We don't know that. Trying to solve for N, so to isolate N, we're going to divide by R times T. Divide by R times T. That will give us the number of moles. So plug in our values here. Our pressure is 2.00 times 10 to the 4th. Our volume is 20 liters. divided by our gas constant is 8.31. That doesn't change. And then our temperature, gave it to us in degrees Celsius, add 273. 28 plus 273 is 301 Kelvin. So times 301. So let's get rid of our variables here. So to solve for n, take 2 times 10 to the 4th, or looks like 20,000. 2 times 10 to the 4th times 20 divided by 8.31 times 301. To 3 sig figs, we get an answer of 1.6 times 10 to the 2nd moles of N2 gas. Or we could write that as 160 with a decimal to represent those 3 sig figs, mole of N2 gas. Okay, so you're always going to start with PV equal. Here's our final answer here for our sample problem 12.5. You're always going to start with PV equals nRT, and then you may have to solve for one of those other variables by doing the algebra. So I'll give you a practice problem or two, but I'm ready to move on to something else, as I'm sure you are. Go ahead and do that practice problem or two. I'm going to post a quiz kind of test, and then I'll give you guys basically till, I'll probably have that due Monday night. So that'll be your work today, and then the beginning of next week. You can sit down Monday and do that test for me and submit it. I'll make it due at midnight on Monday night, the gas law test. So hang in there, keep doing the work. Appreciate you guys. Take care. Have a good rest of the week.